Hey everyone, welcome to our fifth episode of the OpenTelemetry Bootcamp. As always, I'm Eran Gabiner. With me here, Michael Haberman. Today, we're going to deep dive into custom instrumentations. We discussed it early on, the concept of instrumentations and how important are instrumentations for your traces. Eventually, if you don't have good instrumentations, your traces would not look good, would not have the data that you need. And it's a key important factor of how good is your tracing. A lot of good developers out there already created a lot of instrumentations for us. You can find them in the contrib or in other repositories, but every now and then you encounter a situation where you need to do it yourself. And this is what we gonna double click into today. And without further ado, I'll hand over the mic to Michael. And as always, feel free to ask questions. We are on Twitch, YouTube, LinkedIn, and who knows where. But if you ask a question, someone will see it and will try to address it. So have fun.
Cool, thanks, Ron. So, hi everybody. My name is Michael Haberman, and I am very excited to do our fifth episode of our bootcamp. So, a word about myself, so you'll know why I'm speaking about this topic. So, I've been working on distributed application for the past 5 years, almost six now. And in the past 2 years, I did a lot of open telemetry work. So I kind of gained experience, and this is what led me to try and help other people start with open telemetry. So our bootcamp has 6 different episodes, and today we're going to focus about how to customize open telemetry to your need. The first 4 episodes was kind of getting started with the open telemetry, then how to integrate it, then talking about production and high scale. And usually when you're starting to actually work with OpenTelemetry, after you deploy it to production, you're starting to understand that maybe your traces are lacking some data. Maybe you have some data that is not being collected at all, and you want to fix that. So our focus today is to make sure that when you are looking at your traces, or other developer in your team are trying to investigate an issue based on traces and telemetry data, you will have everything that you need. And the last episode, which will be next week, would be assuming that we have all the data that we need and it's instrumented perfectly, how we are squeezing the lemon and taking everything that we can from it. So this is a live session. As Aaron said, you can feel free to ask questions. Will be doing today live coding. You can actually follow along. You can take the GitHub repository, as you can see, and clone it and work on the same code base that I'm working. And if you want to be part of this bootcamp, you can join to our CNCF Slack channel and keep in touch not only while we're live, but also after, if you have any questions or something that didn't work and you want some help. So let's get started with today's episode. So our goal for today is, first I'll try to kind of explain to you why we even need to customize OpenTelemetry. What's the motivation there? We'll take a look at things that if you've been with us the entire bootcamp, you may already saw it to some extent, but I'm going to show you a bit with more details. So we will talk about manual spans and span event and span attributes. And the majority of today's session will be about how to create a custom instrumentation, when to create it, and how to do it. So let's get started. So OpenTelemetry by default is going to collect traces and traces only automatically. And the way that it's doing that is to introduce some instrumentation. Instrumentation are going to be attached to a specific library within your code, your HTTP library, your cloud vendor library. any kind of library that you're using could be instrumented. And then when you're interacting in your code with that library, it's going to automatically instrument this interaction that you have and create spans based on that and send it to our OpenTelemetry collector and create a trace. So for that to actually work, we need to have instrumentation to any library out there, which I'm guessing that you probably understand that's not possible. So there are going to be some libraries that you just don't have instrumentation to. Maybe because they're not that popular, maybe nobody just did it, or maybe there is some problem to actually instrument it. So in any case that you have missing instrumentation, you may need to do stuff on your own. And then you may have an instrumentation, but going to be some missing data, just some data that you want to collect and it's not there. Maybe there is something specific to your business logic that you want to collect and is it present? And maybe the traces that are being generated is not what you expect to see, it's not what you want to see. And then you may need to alter OpenTelemetry a bit. Keep in mind that OpenTelemetry create traces the way they see fit, which I guess is work for 90% of the people, but maybe you have a unique use case that you want to see something differently. You're in charge of your application, you're in charge of your production environment. If you need something else, that's legit. So you need to know how to get there. So let's talk first about adding more data to OpenTelemetry. So I'm referring to currently to auto-instrumented data and traces that are generated automatically, but you want to add something new. So you have three different options. Option number one is there is a trace and I want to add an additional span. I want to add more spans to my trace so that I'll have a clearer picture. So for instance, maybe you are not having instrumentation to a specific database that you are using. Maybe you're using a very rare database and there isn't instrumentation, then you can just add more spans. And another option is to take existing spans and to add more data, more attributes to it. That means that you're taking the one that is already there and just add more data, or you can add events to the span. So those are going to be the three options. I am going to review them in a second. And after we will review them, each one of them, I'll kind of show you this diagram that I created on how to choose which one, in which case you should use which one. So a quick reminder, what's create span? So create span means that we are going to change the timeline of our trace. Basically, we are going to say, hey, from this point in time until this point in time, we are going to indicate that something happened. It means the main cases that you should think on doing that is maybe there is a network activity that was done and you just don't have instrumentation to. Maybe you have something that it's very, very important for you to kind of understand the timing for it. So that's another use case. And maybe you have some scenario where you have few traces that are separated and you would want them to be aggregated. For instance, if you have a timer in your code that is going to fetch some data every 1 minute and you're doing 3 calls, they won't be aggregated together unless you do a manual trace. If you don't remember how a manual trace look like, let me give you a quick reminder of how it looks. So as you can see here, we are grabbing the tracer and we are creating a new span. And after we created it, we provide it with a name. We can close it. That's the whole thing. If you want to create a new trace, it's a new span. That's very, very simple. I do want to say one thing. Creating spans means that we are collecting a lot of data. There is a bunch of data that is going to be collected for every span and it's going to be transmitted. So I wouldn't overuse it. We once met a company that took the span to kind of instrument every function in their code, although it creates great details of understanding each function, how it's being executed, how long it's being executed. It's going to create an endless amount of span and just not the right practice to do. So that's about creating spans. Once you have a specific span, you can add more attributes to it. And you would usually do that if you have some business data that you want to add. For instance, you want to know what's the user ID, or maybe this user is a paying user or a non-paying user, the account ID. So data that is going to help you to search the specific trace, understand the importance of that trace, so any kind of business data. But it could also be operational data. So maybe you are looking at the span of creating a new connection within a connection pool, and you want to know what's the pool size, and maybe that's not present and it's important for you, so you can just add that. And sometimes it's just logical decisions that were made and you want to explain the decision, so you need to add some logical data. So for instance, you have a trace, and this trace is going to behave differently depending on A/B tests. So you have two variations of it. So maybe you want to say, hey, this trace is variation A and this trace is variation B, so it would make sense. And looking on how to set attributes, so that's kind of easy. So what you do is you grab the trace that you have, you set an attribute, and it's a simple key value that you can provide. The key is whatever you want. The value is a string, so you can put anything that you want within that specific span. The last thing that we're going to talk about regarding spans is we can also attach events to this span. And that's starting to be a bit confusing because we have span attributes, span events. So in a second, we'll try to figure out why we have both. So a span event, it's something that occurred in the current span that you're working on. And it's actually happening within a span. And when I say within a span, so a span, what the name suggests that it's going to span over time. It has a start point and it has an end point. So the span event happened somewhere between the start and the end, and there is usually a meaningful it is meaningful when it happened. Unlike span attribute, where you don't know when this data came from, span event usually represent a specific time. So maybe you're running a DB query, and this DB query needs to create a new connection. So that's going to be interesting when this connection was created and how long it took it to create. So that would be an interesting use case to have a span event. Maybe an exception was thrown and you want to record it, to log it. So then you would do that. So maybe you have a network activity which take a long time, and usually network activity you have two phases, even three phases: having a connection, downloading the data, and then deserializing it, or deserializing it and then send it. So if you want to have those events, you can add it yourself and then have the understanding how long things happen within the specific event. And let's take a look at a specific event, a specific event. So we are grabbing the active span, and then we just adding the event. An event must have a name, and it could, if you want, to have any kind of payload that you want. Again, it should be serializable, but any kind of data that you want. So how are we making a decision? How are we choosing when we use span, when we use span event, and when we use span attribute? So first of all, if it's important, it has duration, most likely it's a span. And if it doesn't have a time, and it's just some data that you want to add, it would be span attribute. And if it did happen in a specific time, but it doesn't actually like span over time, or it's not that significant, then it will probably span event. Or we could look at it in this approach. We can ask ourselves, does it have a start and end time? If the answer is no, we can ask, does it occur in a specific time? If the answer is still no, it would be probably span event. If the answer would be yes, if the answer is no, it would be a span attribute. If it would be yes, it would be a span event. But if the answer to the question start and end time, does it have it? The answer is yes. Then I would ask, is it important? If it is really important for you, yeah, create a span. If it's not that important, you can also go with the strategy of having 2 span events, and then it would kind of give you the time and you can understand how it looks. So this is what I would do. This is the true decision that I'm having in my head when I'm altering the data of OpenTelemetry. I'm kind of want to have the data that I need, but also use the right tool for that. So that's the rule of thumb that I would use. I hope it helped you to take a decision as well. So this is the I would call it the easy part, right? We are taking OpenTelemetry kind of as is, and we don't need to understand a lot of OpenTelemetry in order to do that. It's kind of simple function, just use the right tool at the right time. But this is mostly referring to the situation where I have the data that I need, right? I understand what's happening. I just want to add an attribute. I want to add an event. I have some specific network activity that is not being instrumented. Okay, so I'll add a specific span right here. The thing is starting to be more complicated when you're just missing an instrumentation. There is an entire thing that is not being collected, and then you need to start to work a bit in a more complex way. But we will see in a second that although it's complex, it's going to really simplify how your code how your code turns out how your code turn out in the end to look like. So let's talk about custom instrumentation. Sorry, it's the end of the day for me, and my throat is a bit sore. Okay, so the question is, I said that when you create a manual span, what you can do is you can instrument, for instance, a network activity that wasn't instrumented. So I can, if let's say that I'm using WebSocket, that's the demo that I'm going to show you in a second. I'm going to show you that WebSocket is not being instrumented, and it doesn't have an instrumentation. There is an interesting reason why, but it's just, it doesn't exist. So you could just say, okay, I'll create a manual span every time that I'm using WebSocket. Now let's imagine that you have 20 microservices, not a lot, but 20. And each service has like 5 different interactions with WebSocket. Now that means that you have 100 places in your code that are going to use WebSockets, and this is a lot of work to do, right? You need to do a lot of work in order to instrument this data or manually instrument that. So maybe the reason for you to create a custom instrumentation is you just want to have everything in a single place. That's one motivation that I would use manual instrumentation, that I would use custom instrumentation. The second reason is when you start to have manual span in your code, that means that your application code, your logic code, now also contains OpenTelemetry code. That means that you need to have a certain level of OpenTelemetry knowledge spread out throughout your developers. If you're a small team, maybe that's fine. If you are, a medium large team, I would say that it's a bit of an issue because it's hard to spread knowledge in your organization. And when you're doing custom instrumentation, you just don't need that. And the third reason, and this is why I did most of the instrumentation that I did, it's just to support the OpenTelemetry community, just to contribute some instrumentation. So every time that we worked with OpenTelemetry and we had a missing instrumentation, we would just create it and contribute to the OpenTelemetry community. And that's also a very good way and reason why to do a custom or auto instrumentation. Let's talk specifically about WebSocket. I'm referring specific to Node.js. As you know, this bootcamp is entirely using Node.js demonstrations. So in Node.js, we have a library called the WS for WebSockets. And WebSocket, it's problematic in terms of auto-instrumentation. So WebSockets are just kind of sockets, HTTP-based, that allows you to communicate between services in a one-way method thing. That means that service A can send message to service B, but when service B gets the message, it can't respond on the same message. It can, however, respond in a different message. It can send a message back. So that's entirely up to you. You can do that if you want it to. But it's a one-way thing. And when you have one-way thing, it's an interesting thing, because if you would see how company use it, you may see people really use it like an RPC, like a remote procedure call, just send a message, just it. And you may see that it just want to have async communication, but you will see service A calling service B via WebSocket and then respond in another message, and they would want to see it as a whole trace. So that's the first problem, that it's a one-way thing and multiple implementation and different implementation. And the second thing, which is even more problematic, we don't have the ability to, when we send a message, to send metadata along it. And if you recall, OpenTelemetry uses metadata in order to inject the context. So when service A is calling service B should know, hey, I got this message from service A. And the way that we do that, for instance, with HTTP, is we are adding the headers. In the headers, we're adding the trace parent header, which kind of tells service B, hey, this is your parent, and this is how you should behave with this specific trace. When you don't have any kind of metadata, you can't propagate the context, and then you will have a broken trace. You will see that service A sent a message, and you don't know where, and in a different trace ID, not in the same visualization of the trace, you would have that service B got a message, and that would be the root of your trace. Okay, so this is the reason why it's very hard, or even problematic, to create an auto instrumentation, because it could be used in different ways. It could be used either as an RPC or as an async messaging mechanism, which creates two different types of instrumentation. And also, if I can propagate the context in a metadata way, that means that I need to affect the actual data, the payload of the message, and that is something that you don't want to do. So imagine you installing some instrumentation, and then the payload that you send between services is going to change, and it's going to maybe affect your code. So this is why we don't have an auto instrumentation supported by the community. However, if I am the code owner and I decided that I, as a code maintainer of my application, are willing to decide I want it to be specifically looks like an RPC call, and I do agree for the trace parent header to be sent in the payload itself, then we're good to go. Let's do this instrumentation, right? So this is the decision that you're going to face. You're going to say, okay, now I can either create a manual instrumentation for each interaction in the code, or I can have my own custom instrumentation, which is kind of an auto instrumentation that I created. So let's stop talking about custom instrumentation and let's start see what we have in our code base. So if it's your first time here, we have a demo application. Our demo application consists of two services, the item service and the user service that communicate with one another. Each one of them is starting a tracer file. It's two different processes. The item service is its own process, and the user service is its own process, and each one of them is consuming the tracer file. Both the items and the user service, as you can see here, and the tracer file have all the necessary configuration that you would need in order to get started with OpenTelemetry. So what I did here is in my item service, I have a /ws, which stands for WebSockets, and I am creating a payload. And once I created a payload, I am sending this via the WebSocket send and just return to the browser JSON WebSocket true. So if I would go right here to /ws, you can see that I got WebSocket true. And if you would look here, this is the terminal for the user service. We can see that we got the hi over WS. And that looks like so. You have the connection, and then you have a message, and we're just printing the message. So that's the process of just implementing WebSocket. So before I'm jumping into showing you exactly what we need to do in order to create custom instrumentation or auto instrumentation, I want us to do it for a second with a regular manual instrumentation. So the first thing that we would do is to create a span. So we're going to our tracer, and we're starting a new span, and we're just providing it with a name, send the WS message. And we're going to set an attribute so we'll be able to see the payload. And eventually, after we send the actual message, we close the span, start the span, attach some data, close it. Pretty straightforward. Let's do the same for the user service. So in the user service, I am going to do almost the same thing. So here, what I'm going to do is I am going to start the span the same way, and then add the span, end the span. And also, I am adding the payload right here, so we'll be able to see it. And now, let's think for a second. I'm going to go back and re-invoke the /ws message, but what we expect to get from the visualization layer. I expect to see a /ws. I want to see this HTTP span. I want to see a manual span for sending WS. I want to be able to see the got WS message in the same trace. I expect it to be in a different trace. And let's see if that is the case. So I'm sending a new one. Let me fetch the latest one. So that's for now. And you can see that we have the /ws and send message. We can see that the payload is correct. That's great. Let's move to the user service. And in our user service, we can see that we have only one span. That's not the correct one. I have things that are running in the background. Let's see that it's actually worked. Oh, I don't see that it was written. So I don't see that we actually got the message. Let's see, we are doing that. Let's try again. So for some reason, it's not writing. Let's rerun it. Maybe something didn't compile the way it was supposed to. Let's review it again. Creating a span, sending the payload. That's looked great. Then we are starting a span, writing it, closing a span. Looks fine. Let's try one last time. Okay, now it works. For some reason, we needed to rerun it. So now we can see that we got the the WebSocket message with the payload, but they are not connected. In order to connect them together, what we need to do is when we're sending the message, we need to change the payload. So I am changing the payload right now. So I took the payload. I am assuming it's a JSON one, which is a very big assumption. So if you would use string for that, it wouldn't work. It has to be a JSON, at least in this specific way that I implemented it. And once it's been injected to the payload, and please do remember that the payload currently contains only message. Now I'm going to inject the trace parent there, and when I'm going to get it in the consumer side, in the user side, I am going to get the propagated context, which I did something wrong here. Let's see what I did wrong. Okay, now I fixed it. So we are getting from the payload, we are extracting the propagated context, and when we're creating a new span, we are using that context. Basically, we're telling to this span, hey, when you're being created, please look back and see who was your parent and create it with respect to your parent. So let's go back, rerun the service, rerun the request, and let's make another search. And I think that we have like a problem with after I am making changes. Yeah, I think that we'll need to like close it and rerun it after we make changes. Hopefully it won't be too annoying. But now we ran both services and sending again the request, fetching, and look at that. Now we are having /ws, then we are sending the request, and as a child of that message, we have the got message. And if we would look at the payload had changed. So currently, our payload has trace parent along with our payload. That means that we changed the application code.
That's amazing. You might just actually touch it during this demonstration, but we have a question from the audience, from Andrew. How can you actually combine between auto instrumentation and manual instrumentation? Can you associate a span context with a tracer under the hood?
Yeah, so actually, let's take a look at that. So the reason that we got an active span here, right? We are using the active context currently. So the HTTP auto instrumentation created a span for us. And when we are starting a new span, we're starting a new span, and that span is already the child of the /WS. So if we take a look right here, this is an auto instrumentation, this is an auto instrumentation, and this is a manual span, right? So
Nice.
basically, when you're creating a new span, OpenTelemetry automatically is going to correlate it to the right span, whether it's manual or automatic one.
So what you're basically saying is that we can use manual instrumentation in order to enrich an existing auto instrumentation that we have.
Yeah, definitely.
Cool.
Okay, so looking at our code currently, um, you know, our code, I would even call it a bit dirty with all kind of OpenTelemetry related stuff. So all of this is specific to OpenTelemetry. This is specific to OpenTelemetry. In the user service, it's even worse. Like all of that is OpenTelemetry, and I wouldn't want my code to look like that. I would want my code to be much more cleaner. So what I can do, I can go to my tracer and add auto instrumentation for WebSocket and make the same behavior that I have here just automatically. So it would work absolutely automatically, and you won't need to do anything yourself. So let's go ahead and make that. So I am going to my tracer, and when I'm looking at my tracer, I am going to register the instrumentations. When I'm registering the instrumentations, I can just provide here the list of all of the instrumentation that there are anywhere. So those, the Express, the REST framework for Node, the HTTP, the Redis one are all things that I just grabbed from the open source community, and I use them as I want. But here I have WS instrumentation, and the WS instrumentation, you can see it right here. This one is a local one. So I have the WS instrumentation folder, and inside it I have the WS TS. That's going to be the file that is going to have the auto instrumentation. So let's see what an auto instrumentation looks like. So I started with just the blueprint of an instrumentation, so you won't see all the boring coding. So what we're doing here, we are extending an instrumentation-based class that is going to help us with providing all kind of interesting things. And then I created a constructor. In my constructor, I provided this instrumentation with a name, my WebSocket instrumentation, and a version for that instrumentation. And then we have the init function, and everything that we're going to do is going to work in the init function. The init function, you can see right here, was called. This is the WS init, and we are going to indicate that every time that the WS module is going to be loaded, this function is going to be invoked. And this is kind of a magic. And this magic, the instrument node module definition, so you can see we are getting it from the OpenTelemetry instrumentation. So this is something that you're getting automatically for OpenTelemetry. Under the hood, it's just observing which modules are being loaded. And once the module that you're interested in is being loaded, you're just getting a callback. And this is the callback that you are getting to patch that module. And this is the module that you are getting to unpatch the module. So if somebody, for some reason, wants to unpatch specifically that instrumentation, you can do it right here. And when you're patching it right here. So every time that we're requiring the WS module, and that's happening right here and right here, then this callback would be called. The other parameter, this is a version limitation that we could do. So maybe we support only specific versions. Maybe, I don't know, WebSocket had version 2 and now it released version 3 and we can't support version 3 for some reason. Then we would know not to be loaded if we don't support it. For the purposes of the demo, I just put a star, which means anything. Now, once this module was initialized, the callback would be called. And I printed it here 3 different messages, printing the module version. And you can see that the module version, it's 8.2.3. And I'm going to be interested in two functions. Function number one is the send function. I want to see that I want to create a span every time that the send function is being called. Basically, I want to make those lines of code happen every time that this function is being called. So I'm interested in the send function. And also the user service is working on the on message, right, on the on function. So every time that the on message is being called and the type of the on message is a message, I also want OpenTelemetry to start working, and I want to do this logic. So what I did here, I just printed the version and I tested that I do have access to the on function and to the send function. So now I have access to both things, right? I have access to the on function and the send function. I do want to comment it out so it won't interrupt us. So no more instrumentation. So we don't need this, 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 and this. And now we are manual instrumentation free, and everything that we're going to do is going to be part of our auto instrumentation or custom instrumentation. I forgot to mention that lastly, we need to return the module that was exported, and we're not going to change it, so it's going to be just out there. The first thing that I'm going to do, I'm going to start work on the send message. And in our base class, the instrumentation base, we have something called wrap. What wraps allows me is to be able, when the function is being called, to have my own callback. So what will happen is that my callback will be called first, and I need to make sure to call the original function, which in this case is going to be send. So from the module that was exported in the prototype, let me copy that. So that's the object that we are looking at. And the function that we are interested in is the send function. And whenever the send function is being called, we want to get a callback. And we need to have access to the original method. So every time that we are going to have a send message being called, then we are going to have a callback right here. And as you can see, we already have some errors. You will see a long time that we are doing changes that are going to cause errors, and we're going to fix them as we go. So first thing first, let's have a message here saying that we are wrapping the send method. So we will have a good logging that will show us that it's in fact happening. So that's the first thing that it's going to be happening. Then we need to return the function. So every time that the send message is going to be sent, this function that I'm currently typing, this is the one that is going to be sent. Because it's kind of a replica of the send message, I need to have the same exact arguments that I had when, that the send message has. So I'll go to the send message, and I'll look exactly what I'm using, and this is the parameter that are being used. If those are the parameters that are being used, those should match exactly the one that I'm using. So now I have a function that is similar in the parameters that it's getting from the original one, and you can see that we don't have any errors anymore because we created a function that matches exactly the send message. But we do need to do whatever that we want to do here. So let's do console.log, and first see that, let's say ws.send is called. Okay, so If I'll reproduce a request right now, so I guess it won't work. I guess that I'm going to have some issues. You can see that we didn't receive the message in the user service, but we did have the WS send is called. So this actually ran. So now what I need to do is I need to have the same logic that I did when I did it manually. So we need to create a span. So let's do create cons send span. That would be self. Self is the current instrumentation that I'm having. And I'm going to my tracer and start span. And let's do send WS message. And let's write here custom. So we will be absolutely sure that that is the custom one. Now I got I have access to my data. That's the data going to be exactly this one. So it is going to be a string in our case. So I'm going to parse it as a payload. So it's going to be JSON parse and the data. After I did that, I need to grab and I need to inject the context as we did earlier, right? We did this part. So I need to inject it. So I'm taking the payload and putting it in the send one, and I can add the payload. So I can do set attribute payload, and we want to have a JSON stringify on the payload, so we will be able to observe the payload. And then we need to do to close it, right? We need to close the span. And eventually we need to actually call the original function. So when I am going to use this one, so this would be the original function. So I have a result, and let's result the original function. And this is a bit specific to, let me grab it real quick from here. So this is specific for how you would call it in JavaScript. I guess different languages have different implementation. So what we did here, we changed the function of send so it would do whatever we want it to do. And then we called the original one so it would do the implementation of WebSocket. If everything worked, what will happen is when I'll click send, we are going to have a span created. However, we won't have the context propagation working yet because we didn't do anything with the on function. So let's verify that it's actually working and I didn't do anything bad. So first of all, it didn't crash. That's great. We did got the received message. So the WebSocket is still working, even though I patched it and did all kind of things. And we can see that the WebSocket was called, so this function was running. So we expect to see this in our trace that was created. Let's take a look. So in the item service, we have something a few seconds ago. And here we have it. We have the send WL message from our custom instrumentation. So we are done with handling the send part. Now we are moving to the on part. And if you remember, in the on part, what we did is we took the payload, extracted the context propagation, created a span based on that, and closed it. So now we'll do it, but we will do it automatically. So the same thing is going to happen right here. So in our this, we're going to have a wrap, and you know what, let me even copy it from here. So we won't need to type everything all over again. So we have a function for that, and it's going to be on instead of send. And I do want to print, so we would actually see whether it's being called or not. So on was called, and I want to ask to see the not the EV, the just on was called. So let's see that it was actually called. Okay, we're not returning anything, so that's going to be a problem, but we would fix it as we go. So same as before, the first thing that we need to do is to return a function that would simulate the on function, and that would be a function, and it's getting two parameters. It's getting the event one, and it's getting the original listener, and it would be a function. And let me copy it real quick. So now we have a function simulating the real, the real on function of WebSocket, and I'll print that as well. So we'll have on was invoked. Cool. So now the on function is really invoked, but here we have two different cases. So if you see here, we have two types of on. On is event emitter, and on is happening when you having a close, open, message, error. There is tons of cases where on is going to be invoked and or being registered, and it's actually register would be a better name here. So we want to patch the function. We want to change the function only on the message. I don't know what closing is doing, and I don't really care because I only care about the actual message. So let's do that. So what we are going to do is we're going to say if the event is in fact message, I want to do one thing. If not, what I want to do is I want to return the original function, not the origin, the original function, and then to do apply, and to do this, and pass the same argument as it was supposed to have, the original listener. So now we are calling the same function. So basically what we did here, we did nothing, right? We had a function that if it's not message, it's just going to return, to invoke the same function it was used to. In message, we want to do something a bit more complicated. So I want to do here a wrap function to basically to wrap the message function. So this would be a function that is going to get some arguments. And this is going to be the implementation when message is being invoked. I do have the original one, but all the magic that we did here is going to be implemented now in our auto instrumentation. So I didn't put args here. So what I'm going to do, the first thing, we need the payload. So const payload, and then we need to parse it because it's going to be a JSON, and we are going to do args string to make sure it is a string. Now we got the payload. We can grab the context as exactly as we did before, and we need to create a new span. So let's create a span. We got the span, so got WS message, and we're using the propagated context, and then we need to actually just close it, right? So all we need to do right here is we need to do WS span to end it. We didn't use the original function, so what we need to do here is we need to take this function and we need to actually invoke it. So let's do exactly that. Let me grab it real quick. And we are calling the original one. I hope I didn't make any mistake here. We will see in a second. Oh no, I did make a mistake. Let me fix that really quick. Okay, so yeah, so what we're doing here, we are calling the original function, and let's see if that works or not. We will see in a second. Okay, so let's do number 7. Cool. So we can see here that it was received, which is good. We are happy. I'm not exactly sure about whether the instrumentation is going to work or not. I think I did a mistake. So it was a few seconds ago. So, and we can see that the context wasn't propagated. We can see that the payload is right. We do have the trace parent, and we need to fix that. So what's happening here is that we are not using our function, right? We need to use our function, and let's do that. So let me check that I'm real quick that I didn't do any mistakes. I think I did. So in the case of the if event, of a message event, we need to return. And what we need to return is we need to return the wrapped function, because this is what we want to be executed. Let's see if that works or not. Why are you upset with me? Oh, yeah, we need to do apply. And the argument would be this and this. Yeah, I think that would work. No, because it doesn't have that right now. I think I'm missing something. Wait a second. Let me see what I did wrong, because I did do something wrong, because it's not working as we expect it to. Okay, just a second. Oh, no, not what I wanted to do. So this is what happens when you do live coding. You miss something. So
we forgive you, Michael. Don't worry about it.
No, we can fix it in a second. Let's see what I'm missing. So the problem is that we created a new function. That's exactly what we wanted to happen, and we need to call this function, but for some reason it's not being called. One last try. Okay. Let's see if it's working. No, it's not working. So I did some mistake here, but overall, what's happening here is that we are creating a new function, and that function is, this one should be called, and then the context will be grabbed. We would open the span, we would close the span, and everybody would be happy, and everything would work the way it should work. My apologies, I'm missing something, but also we've been through a lot. When I will upload it to GitHub, it would be fixed. So just
cool.
to close,
thank you, Michael. For this really amazing live coding. It was a tough one. Maybe just a second before moving forward, an interesting question, something that we're also dealing with in Aspecto from time to time, about like the context propagation, propagating headers. There are, the standards, the W3C trace context, but what if we need to use, something else? We need other headers because we have in-house proprietary software or some other reason. Is it recommended to do it or not?
So could you repeat? I'm not sure that I got it.
So in terms of propagating headers, there are obviously the standards like the W3C trace context that are encouraged to use. But what if we need to use something else? We have like in-house proprietary software or some other reasons that requires to have new headers.
Yeah. Okay, got you. So if you must do that, so yeah, you can. I wouldn't recommend to do it, but you can do that. So the way that you do it is you just go to your provider, and you can then define it in it's not today. There is something that doesn't want to help me find what I'm looking for, but you can change it, and you can decide how you want your context propagation to work, and you can define whatever thing that you want. So if you want to change, here it is. If you want to change the propagator and do your own implementation, you can just provide it right here, and then you are good to go.
What should we expect if we're doing something like that?
What should you expect?
So like what pitfalls might happen?
So the problem that first of all, that means you need to do it all over your code, all of your in all the different services. If you have different languages, you need to implement it several times. The problem that you may encounter is if you're having some kind of a third party that will have an issue. That is not will have an issue. Will also use OpenTelemetry. Then you won't be able to communicate because they would probably use the default. So, for instance, GCP, Google Cloud, are working with OpenTelemetry, and then they're putting their own spans, and then it wouldn't work. By the way, I think I fixed it. So let me see. Like I found what's missing. So I didn't return the original function and called the one that we wrapped, and I have a problem with doing demos that doesn't work. So let's see if it's actually working or not. It is working. Oh, now I'll be able to go to sleep quietly. So yeah, now we have the context propagated and no OpenTelemetry code in our logic, only in our manual instrumentation. And cool. Any more questions before I summarize today?
No, I think we can wrap it up. We're already behind schedule.
Yeah, so I would just say that you can do a lot with OpenTelemetry. You can configure it, you can extend it. It's very, very easy to change everything that you want, and you just need to learn and teach your team how to use it the correct way, I would say. So thank you very much, and I really hope to see you in episode 6. And so are we closing today?
Oh, sorry, I was on mute. I was just asking if you can if you can elaborate for 2 seconds about what we're going to hear in episode 6.
Yeah, so what we're going to speak on episode 6 would be mostly on how to take OpenTelemetry data, not only to observe what's happening in production, but also to talk about how to test stuff and how to use OpenTelemetry in pre-production. So that would be our focus.
All right. See you next time. See you in a week. Bye, everybody.
Yeah, see you. Bye-bye.